Hello everyone, my name is Carlos and today I will present my work names Managing Consensus-Based Cooperative Task Allocation for IoT Networks. For that, we will follow this agenda with introduction, our problem, state of art, the mechanism named task, evaluation, conclusion, and future works. IoT is present in different application domains like smart security, smart home, smart health, and smart industry. However, the industrial can can be utilized IoT in different type of microservices like automation machinery and inventory control, robots, and different type of sensor in the plant of industry, logistic, and it's possible to control all these services in the unique place. So, what IoT is so important for industrial application? Because IoT can provide different type of service and improve better service for the different applications in the industry. However, the IoT have some challenge to be better and develop in the industrial scenario. So we need to overcome some challenges like service integration, resource allocation, quality of information, data dissemination, and management all these IoT objects handled with heterogeneity of these objects. So for do that, we can use some services like task allocation. However, task allocation in the IoT scenario, we have some problems because all the objects is not the same. What is not the same? So each object is a unique object in the Internet of Things. So they can be different. They can have be different capability. They can have be different resource power. They can have be different storage. So how IoT handle it with this heterogeneity? So you can use multiple sensing capability, preserve quality of information, and the task allocation is about that. How can we handle this resource heterogeneity in our device in the IoT? So management the object resource is a complicated task because we have 5 steps to provide the better task allocation in the IoT. So normally task allocation is composed for the task allocation, the service. We need to waste of resource, so we need to preserve this resource. We have handle it. We need to handle it with fails. We need to improve better quality of the information collected by the device and preserve the data dissemination service. So, what's the problem in the scenarios like industrial? So, in scenarios dynamic like industry, we have different interaction among all the objects in the IoT. So this interaction affects how the task allocation handle this device. So this brings us our problem. We need to handle and guarantee a fair task distribution among all the objects in the IoT, considering the low consumption of resource for these objects. So normally, task allocation requires some benefits or some we need task allocation to do management all objects to maximize of the resource this object. So normally in the state of art, people utilize approach like object utilization, distributed consensus, heuristic algorithm, and task groups. So when we think about to develop a solution for the task allocation problem or service, we need to consider collaborative and dynamic capability identification, and we need most of all preserve of research these objects because not all the objects in the IoT have capability to do different type of service and save energy. So our objective is to create or handle the density of the network, consider collaborative and distribute tasks among all the objects in the IoT, according their capability to do the tasks. So we choose to utilize two techniques: distribute consensus and task group. So these techniques bring us possibility to work distribute among all the participants in the network and collaborative and dynamic in the same time. So for handling this problem, we propose a mechanism named Contask. What is Contask? What Contask do? So Contask is a mechanism for supporting the task allocation service among all the objects in the Internet of Things. So Contask utilizes two techniques or two strategies. We utilize consensus and similarity. For do that, similarity you utilize to evaluate the capability of the nodes, and consensus we utilize to a fair task distribution and a collaboration among all the objects in the network. So we need to preserve some properties for our mechanism. So our mechanism need to be dynamic, considering sensing capability, need be scalable, and most of all collaborative and decentralized. So our system is composed or include three different uh, properties. So first, we have the network with different objects. We have the communication. We have 5 type of messaging change among all the objects, and we have our task model. What is a task model? What the communication model do and in the network? So here is an example of our model. So we have access point responsible for disseminate the task among all the objects, all the leaders objects in the IoT. We have the clusters. We form clusters with a node leader and a common leader, a common nodes. And we have the messengers exchange in the cluster and the access point with all the objects. So for organize and management this infrastructure, we have an architecture. So architecture is composed of two models. The first one is a cluster coordination. He works for maintain the infrastructure of the network. For that, we verify similarity between capacities in the in the in the objects in the network. We compare this capability to form a cluster in the network. The second model is the task allocation control. Task allocation control is responsible for organize and distribute the task among or between nodes in the network. So for that, we have the task dissemination, the task verification, and the whole with all nodes is applied in the network. So how can we handle the density of nodes or objects in the IoT network? So first, we form cluster to establish an infrastructure of the network. Then we consider for form this cluster the similarity of capability of these nodes. So we have different nodes with different capability, and we need put all these nodes together. So we put the node together, create a cluster, elect a leader, and create the first infrastructure of our system. So we consider some equation for form this infrastructure. So we consider the capability of each object have and the number of neighborhood each node have, and we compare a threshold uh, create for evaluate the similarity between capabilities of each node. Then after the infrastructure is already, we can disseminate tasks among all the objects in the network. So for do that, we utilize the access point. The access point check his task list and disseminate a task for the leader. So first leaders registers in the AP, check if the task then they receive is capable, he is capable to handle this task or do this task. If he's capable, he sent a messenger to access point, said, okay, I'm ready to do this task, and run this task for the next time. So this is our model. For simplify, in the next, I show you the cluster and task allocation work together. So first, we change message of capability dissemination. Second, we calculate the similarity between our nodes to form the cluster, elect a leader. After leader is elected, we send a messenger for the access point saying, oh, I'm a leader, and AP or access point have a list of the tasks to do. So the access point send a messenger for our leader, and which leader responds with, okay, I'm accept this task, is able to do this task. And after he send a messenger to the access point, he sends a messenger to his cluster to perform this task. So this is our model and how is the model works. So our evaluation is composed on different type of scenarios. We utilize NS3 simulation. Our scenario is composed for three type of nodes. We have 50, 70, and 100 nodes. Our time is 800 seconds each simulation. Our map is 150 seconds. Our task is composed in our routes of simulation to dispatch 10 tasks. Each node is is configured or set with three basis sensing function: temperature, humidity, and presence. But all the nodes can set with different sensing function like light, machine states, pressure, and reservoir. Each task takes like 60 times. For communication, we utilize the 6LoWPAN over IPv6. We choose this because is a low network, so we don't need the utilize other protocol communication. We have 35 rounds of simulation with 95% of confidence interval. So our objective is to evaluate the performance of Contask in a service like in the service task allocation. So we choose some metrics to evaluate our mechanism: number of cluster, number of task allocate, number of allocate task, cluster apt to perform the task, cluster inapt to perform the task, the latency of the accept time. So it's important to our system, and the degree of similarity between task and leader to perform. First, we consider the evaluation of cluster. So we evaluate the number of the former clusters in our network. We have a good number of clusters formed, but we need to consider if not all clusters is apt to perform some task. So normally the cluster idle is incapable to do the task. So he needs to wait and save resource for another round the task. So first, to evaluate this, we we create a scenario to do this model. So normally, the inapt clusters are significantly higher than apt. Why that? Because we don't need all the cluster to perform a task. So if we have a minimal number of clusters perform a task, the others cluster can save resource for another task or another round of tasks. So we have dispatch in all scenario. All clusters capable to do different tasks. So in some scenarios, like with 57 and 100 node, we are able to perform over 90% of the task dispatched. Our latency is a low latency. I consider that because we have the median like 15 milliseconds to 40 milliseconds in all scenarios. So it's a low latency to accept a task and start execute this task. And we have finally the similarity between the task and leader. So how much more closer than one is better for the simulation sorry, is better than, is closer than perfect match. So we have almost test perfect match with the cluster leader. So conclusions about the work. We analyze and we think it's possible to collaborate and handle the network with a service like task allocation in a way consider the capability of the nodes and how they can perform and save resource for different rounds of tasks to be done. So normally the task allocation in our scenario is based in dynamics in base in resource preservation. We need to reconsider the capability of nodes, and we work in a dynamic and distribution way. So for future work, we pretend analyze our scenario with multiple simultaneous tasks in the same time. So our and we pretend evaluate also in different domains of application like smart health, public security, and others type of scenario, and a different type of mobility in the service of the task allocation. Here is our research team, and thank you for your attention. I'm open to question, and if you want a question, you can send me an email. And thank you.